higher derivatives of a function. If y equals f of x, where f is a differentiable function with respect to x, then its first derivative is y dash equals dy by dx equals f dash of x, and it represents a new function. If the first derivative is differentiable with respect to x, then its derivative dy by dx for the first derivative is called the second derivative of the function f. And if the first derivative is differentiable with respect to x, then its derivative d by dx for the first derivative is called the second derivative of the function f, and it represents another function. It is denoted by the symbol y double dash. Y double dash equals d2y by dx2, or you can say dx squared, which equal f double dash. By repeating the process of differentiation, we get the third derivative of the function f, and it is denoted by the symbol d3y over dx power 3, and so on. Note that d2y by dx squared is read d2y by dx squared. There is a difference between d2y by dx squared and dy by dx all squared. The first here refers to the second derivative of the function, whereas the second refers here to the square of the first derivative. Example: first, or you can say example 1, find the second derivative for each of the following: a, y equals 2x power 4 plus 3x minus 5, b, y equals x plus 1 over x minus 1, c, y equals sine 3x minus 2, d equals root 3x minus 2. First, you have to remember the rule of differentiation. If y equals x power n, then dy by dx equals n multiplied by x power n minus 1. X power n minus 1. Solution. First, we solve letter A. Since y equals 2x power 4 plus 3x minus 5 and the x belongs to R, then what's the derivative of x power 4? It will be 4x power 3, and multiplying 4 by 2 you get 8, and so on. So dy by dx equals 8x power 3 plus 3, as the derivative of 3x is 3, and the derivative of the constant negative 5 is 0. And the second derivative, d2y by dx squared equals 24x power 2. How we get 24? Multiplying 3 by 8, and 3 minus 1, we get x power 2. We get 2 here. Letter B, since y equals x plus 1 over x minus 1, here we have numerator and denominator, fractional function, and the x not equal 1. Because if x equal 1, you get 0 in the denominator, and division by 0 is meaningless. What is the rule for the differentiation of the quotient of the function? We have f of x over g of x. So what is the derivative of f of x over g of x? First we write the denominator dot f dash of x. F dash of x is the derivative of the numerator minus fx dot g dash of x. G dash of x is the first derivative of the denominator over g of x all square, and of course g of x not equal 0. Solution: d by dx equals the denominator is x minus 1 multiply the derivative of x plus 1 is x, is 1. The derivative of x is 1 and the derivative of 1 is 0. We don't write it. Minus the numerator which equal x plus 1 multiplying the derivative of denominator which equal 1 over x minus 1 all square. X minus 1 all square is the square of the denominator x minus 1. By simplifying, we get x minus 1 multiply 1 equal x minus 1 minus x plus 1 multiply 1, we get negative x minus 1 over x minus 1 all square. So x minus x equals 0, and we have negative 1 minus 1 which equal negative 2. So we have the first derivative dy by dx equals negative 2 over x minus 1 all power 2, and it's preferred to write it on the form negative 2 multiply x minus 1 all power negative 2. Here, when you want to write x minus 2, x minus 1 all power 2 as a numerator, we change the sign of 2 will be negative 2. To get the second derivative, we multiply negative 2 by negative 2 which equal 4, and by subtracting negative 1 from negative 2 you get negative 3 as follows. So d2y by dx squared equals 4 multiply x minus 1 all power negative 3. Negative 2 multiply negative 2 equals 4. Negative 3 minus 1 equals, negative 2 minus 1 equals negative 3. So the final answer will be 4 over x minus 1 all power 3. Number C, y equals sine 3x minus 2 and the x belongs to R. You know the domain of the sine function is R. What is the differentiation of sine? The differentiation of sine is cosine. You must memorize it. The differentiation of sine is cosine. And what is the differentiation of 3x minus 2? Differentiation of 3x is 3 and differentiation of 2 is 0. So dy by dx equals the 3 cosine 3x minus 2. Again, the differentiation or the first derivative of sine 3x minus 2 is cosine 3x minus 2 multiplying the derivative of 3x which equals 3. Then d2y by dx squared equals negative 9 sine 3x minus 2, as the derivative of cosine is sine. The derivative of cosine 3x minus 2 is sine is negative sine 3x minus 2 multiplying the derivative of 3x. The derivative of 3x is 3 multiply 3 equals 9. So the final result is negative 9 sine 3x minus 2. Letter D, y equals root 3x minus 2. Root 3x minus 2 and x is greater than or equal to over 3. It is the domain of the function y. Solution. We write y equals 3x minus 2 all power half plus dy, then dy dx equals half 3x minus 2 all power half minus 1. You have to remember the rule of differentiation. By 3, how we get 3? By differentiation of 3x. So 3 multiply 1 over 2, it will be the coefficient 3 over 2, and 3x minus 2 will be power negative half. As you see, half minus 1 is negative half. Then dy by dx equals 3 over 2 root 3x minus 2 and x greater than 2 over 3, and this is the domain of the denominator. Of course, you cannot write x greater than or equal to over 3 because equal to over 3 making the denominator equal 0 and division by 0 is meaningless. We make the second derivative d2y by dx squared equals d by dx for 3 over 2 3x minus 2 all power half. It is another form for the root. 3 over 2 multiply 3x minus 2 all power negative half equals negative half multiply 3 over 2 negative half multiply 3 over 2 multiply 3x minus 2 power negative half minus 1 negative half minus 1 multiply 3 is the derivative of 3x. So d2y by dx squared equals negative 3 multiply 1 equal 3 multiply 1 multiply 3 equal 9, and don't forget negative, we write negative here, and 2 multiply 2 equals 4. Negative half minus 1 equals negative 3 over 2. And the final result will be negative, don't forget it, negative 9 over 4 root 3x minus 2 all power 3. And x here is greater than 2 over 3. And as I said before, the domain of the function is all the values of x which greater than 2 over 3. You cannot put equal here because it makes the denominator equal 0. Example 2. If y power 2 plus 2xy equals 8, prove that x plus y d2y by dx squared plus 2 dy dx plus dy by dx all square equals 0. Solution. We have y squared plus 2xy equals 8. We have y squared plus 2xy equals 8. By differentiating both sides with respect to x, what's the differentiation of 2y? Y power 2 is 2y power 1 multiply y dash. Y dash is the derivative of y because y is a function of x. Here 2y y dash plus we have here two functions. 2x is the first and y is the second. So we have the first to x multiplies the derivative of y, which it will be y dash, plus the second is y multiply the derivative of 2x, which equal 2, equals, what is the derivative of 8? The derivative of 8 is 0. So we have here, after differentiation with respect to x, 2y, y dash plus 2x, y dash plus y multiply 2, which equals 0. By dividing by 2, to simplify it, what we get, y dash plus xy dash plus y equals 0. We divide by 2, we have y dash plus xy dash plus y, which equals 0, as 0 divided 2 equals 0. Here you can take dy by dx, which equal y dash, as a common factor. So x plus y multiply dy dx plus y equals 0. Again, you can write x plus y all multiply y dash. Y dash is dy by dx plus y equals 0. By differentiating both sides with respect to x once more to get the second derivative here. So we have two functions, x plus y d2y by dx squared plus dy by dx multiply the derivative of the bracket. What's the derivative of x? The derivative of x is 1. What's the derivative of y is, the derivative of y is dy by dx plus the derivative of y is dy by dx equals 0. And here we want to write the result as the required here, How we get this result? We have x plus y, d2y by dx squared, d2y by dx squared, plus when you multiply dy by dx by 1 and you add it by dy by dx, you get 2 dy by dx plus dy by dx multiplied dy by dx, you get dy by dx all squared. It's equal 0. And comparing the result with the required, we notice it is the same. So it is the end of the solution for this example. Exercise: if x squared plus y squared equal 9, prove that y d2y by dx squared plus dy by dx all squared plus 1 equals 0. If y equals 10x, then prove that d2y by dx squared equals 2y multiply 1 plus yx squared. And we will solve it in the second video, the next video. I hope you understand everything here, and if you have any question, you can write it in the comment. Bye bye.